All right, the recording has been started. Welcome, everybody. Thanks for joining us tonight. I will post some links in the chat. If you're new here and you stumbled upon this because someone shared a link, I'll send you a link off to the place where you can sign up for the mailing list. You can add the Sunday night calls to your calendar, and then and you can sign up to host a topic like Andy did for tonight's call. We currently do not have any future topics on the list. So we're not going to meet next week because it's Super Bowl. But after that, there's nothing on the list. So please sign up to host a topic. If you're a mentor, please encourage your students to have a topic. If they're going to do a Dean's List interview and they want something to talk about, hosting a talk here is a great thing to talk about in a Dean's List interview. Yeah, please, I encourage everybody to hit that link. I'll place it in the chat in just a second. Also, someone joined last week, and now I've forgotten who it was, and they said, hey, how do you advertise this thing? Because this is my first time. If anyone's interested, I will create a PDF that you can hand out at your different regionals to get more people to join the call and be a bigger part of our community. So I'll try to put that together for the upcoming weeks. And if anyone here wants to pass it around at the regionals they go to, it'd be great to get more people sharing on the call. All right, Andy, the floor is yours. Take it away.
All right. Well, I figured I'd go through, I did a presentation at Jumpstart, and I'll probably do that first. And then I'm hoping you guys will have questions and we'll have some discussion about your experience last year or whatever you're doing so far. So, all right, what are April tags? Hopefully most of you guys know at least somewhat what April tags are. We had them last year. This is a picture that I took at a preseason event and then ran through April tag processor. But the April tags are those little QR barcode looking things. And as you can see, the processor is able to process them and give information about the orientation of the April tag. So it can kind of calculate the distance and the way that it's tilted. Figure out how to move forward here. Here we go. There we go. So this year there's going to be 587 unique tags. On the field, there aren't that many though. I can't remember what it is. It's around a dozen, maybe a little bit more than that on the field. There's different families. It's 36H11 this year. If you're using Photon Vision or Limelight, you have to choose that. Last time I checked, it was still defaulting to 16H5, which is what they used last year. So if it's not detecting the tags that you printed from this year, check if you're using the latest ones. Last year I presented and this list of possible tags was a lot smaller. This year they are using a different family. So why did they switch from April tags or to April tags from retro reflective tape? The big reason is bright lights, right? We had lights kept getting brighter and brighter, and it's difficult for people to see and difficult for drivers. One year they were kind of making you turn your lights off at some regionals and not at others. And so I think they heard a lot of, it's not happening consistently. So they said, why don't we try something different? So they're less susceptible to field lighting and arena LED signage. I know KnightKrawler and us both had trouble one year at Williams Arena where there was a marquee, an LED marquee up, and sometimes it was behind the target, and we'd go to shoot into the target in 2022 and we'd see the lights on the marquee and then we'd miss. So it's less susceptible to things like that because it's not based on light reflecting back and trying to filter things out. It's based on seeing a tag and processing it. You can also get 3D position and orientation like we saw on the previous slide. You can figure out based on how big the tag is supposed to be and the way that it appears in the camera, how far away it is and which way it's turned. Each tag is also unique. And this is a kind of an important thing is that there are different tags with different IDs and different spots on the field. So in the picture there, that's tag number 1 from last year. So your robot knows if it sees that tag is supposed to be in that position on the field. So if it knows where that tag is in relation to your robot, it can know where your robot is. So having different tags in different spots on the field allows you to know. And then there's less need for calibration at competitions just because it's a little bit less susceptible to light. So you don't have to roll it out and move it around or all the different tags and make sure all the lighting is right. And then, they change the lighting in the arena and you're in trouble. So, last year, this is what the field looked like. I didn't update the slide for this year. There are a few more tags, but most of them are along the alliance wall. There are a couple on your climbing apparatus this year. So there were 8 along the alliance wall, and then they're along the scoring locations and the human player stations. So this was last year. This year there's a couple more. So photon vision is one of your options that I'm going to cover. The other is limelight. You can run photon vision on your limelight, or you can run photon vision on your own coprocessor. We're going to use an Orange Pi this year. We used a Raspberry Pi last year. Some people use like mini PCs, Beeline PCs. It's a simple computer vision solution for FRC. It is built, custom for FRC, so it integrates well with your robot code. It can identify April tags. You can also do retro reflective tape and colored shapes with it. The last few weeks, they've been working on also doing some object detection to be able to detect like a note. I haven't tried that yet, but it might be something you want to take a peek at. And then there's a library that you can add to your robot project called Photon Lib, and it makes it really easy to integrate with the robot. You don't have to worry about network tables or anything like that. You just interact with it like any other Java library. So the hardware you can run it on. You can run it on a Raspberry Pi. We're going to run it on an Orange Pi. Like I said, on a Limelight, they have a custom image that you go download the image, like if you were going to update your Limelight, but you go to grab a different image and then you flash it onto your Limelight. Also, Glowworm was a little device that was around for a while. Variety of cameras are supported. A recommendation is to use a global shutter camera. And this is where there's some benefit to using a photon vision solution over Limelight, because Limelight, at least as of right now, doesn't have any sort of option for global shutter. A global shutter is where it'll take a picture and scan the entire screen at the same moment. So that little animation on the bottom, I don't know how well it comes across on Google, but the ideal is that, you're capturing every frame exactly. A global shutter camera will capture the frame, and it's capturing it not at full speed is kind of the difference there. But the rolling shutter camera, the difference is that that horse and the jockey are moving while the picture is being taken, so it's scanning from top to bottom to capture that image, and it gets distorted. So if your robot, say, is spinning really fast or driving really fast and it sees a tag, you don't want that tag to get skewed or it won't be processed properly. So a global shutter camera is ideal if you can do that. So the OV9281 is a common one that seems to work really well. You can get a USB one that works with a lot of devices, or you can get one with a little ribbon cable to use with a Raspberry Pi. Any questions so far about photon vision? Otherwise, I'll move on to Limelight real quick. All right, Limelight. You guys probably have heard of Limelight before. It's a device that you can buy. There's a picture there of the latest one that he released last year, the Limelight 3. They are a package solution right out of the box where they, depending which one you get, they're like between $350 and $400. I think they're not available right now, but sometimes they are. You can buy them, and then you set it up. You put your team number in there, and you configure a couple of settings about where you're putting the Limelight on the robot, and it just starts telling you where you are on the field. Last year, they released a Limelight Lib helper library that you can go download. I'll talk a little bit about that when I give an example how to integrate it. And in the reveal like video, the marketing video for the Limelight 3, it said global shutter upgradable, but there's been no information about how to do that. So at least as of now, I don't know of any way to use a global shutter camera with a Limelight. But the Limelight, you can do April tags. It also has the bright lights on it if you want to do any sort of, trying to detect or do processing with a grip or whatever. So camera configuration, you want to set the exposure as low as possible. And the reason is because you can capture a picture faster, right? For exposure is how long is the aperture open. So if you can open that quick and close it, you reduce the chance for that tearing with the, if you don't have a global shutter camera or any other kind of smearing of the image. And then you can adjust the brightness or the gain to try to recover some of that if you're not getting quite the contrast that you need. And then as far as resolution, the lower you set the resolution, the faster it's going to process because it has less pixels to look at to pick out the April tag, but you won't have as much range because when it's seeing it farther away, at some point you're going to get where your pixels are so large that you can no longer pick out the tag. So if you want to be able to see from a farther distance, you may want to have a higher resolution, but if you want to have more accurate, fast images, then you're going to want to have it lower. In photon vision, you have to calibrate the camera unless you're running it on the Limelight. If you're running it on a Limelight, the image comes prepackaged with it calibrated. But because on other devices, you can plug in whatever camera you want, you have to calibrate it so that it knows like the focal length and how the camera sees images, because that's how it knows how far away the tags are when it sees them in the image. So there's a 3D calibration steps that you have to go through. You go to the tab and you say you want to start calibration. You print out this checkerboard and measure it to make sure it printed out properly, because the checkers have to be a specific size. I think it's 1 inch. And so like if you print it and your printer scales it down, then it won't calibrate properly. It needs to be the size that it's expecting it to be. And then you hold it in front of the camera like that. It'll find the spaces in between the check marks like that, where it has the blue and the green and the red lines. And then there's a button that you press to say, I want to capture this image. And you want to move it around on all the different spots on the screen at different angles and take up to, or at least 12 pictures. And then say you want to finish calibration and it'll run a routine. And then you can go back and make sure that it works okay. So it's an extra step you have to do that you don't have to do, with the Limelight. And then multi-tag processing is something that both the Limelight and Photon Vision have. If you can see multiple tags at the same time, you can get a lot more accurate, a lot less ambiguous estimate in where you are on the field. So that's something to consider, where you're putting your camera on the robot. If you can get it somewhere that you can see multiple tags. I think this year that's why they have 2 tags right in front of the speaker, is so that you can have a pretty good chance at seeing 2 tags when you're trying to score into the speaker. Limelight calls it mega tag. You want to turn that on if it's not turned on. And then in Photon Vision, they call it multi-tag estimation or multi-tag PNP in some places. And this year, Photon Vision allows you to run that on the coprocessor. Last year, you had to run it on your RoboRio. So there's a setting there that you can turn on that says do multi-tag estimation in Photon Vision. And then in Limelight Live, you say you want to do that, and it'll reduce the ambiguity. I'm going to skip over this. Maybe we'll look at this kind of depending what questions we have. I can run Photon Vision on my laptop. I don't know how well it will work while I'm using the camera at the same time, though. So I might have to skip that. WPI Lab geometry classes are something that you probably want to know a little bit about, because you're going to get some geometry information and where you are on the field. So the classes that are important to know at least what they are is translation. That's a X and Y coordinate. So, where you are in two-dimensional or three-dimensional space, X, Y, or X and Y and Z. A rotation, which is a heading. And then a pose is a combination of those two. So if you say, like, what is my robot's pose? That's where it is on the field. And then what direction the front of your robot is facing is a pose. And then a transform is a vector in rotation to get from one point to the other. So that would be something you'd use when maybe you figure out where you are on the field, you figure out where the speaker is, and you're going to score into the speaker. You would have a transform that would get you between the two. So, and then there's both two-dimensional versions of those classes and three-dimensional. The two-dimensional are usually what we use because it's just we care where we are on the field in X and Y, and the heading of the robot. We don't care how high the robot is off the ground and what direction it's like tilted in, forward, backward, or side to side. We can kind of assume it's driving on the ground and that it's upright. So the coordinate system is something that's tricky sometimes for people because it's a little bit less intuitive that the front of your robot is X, not Y. So facing forward from your robot is X, and then robot left is positive Y, and rotation gets larger when you turn counterclockwise or to the left. A lot of people make this mistake in their swerve code when they first get started. They think, Y is forward and rotation is positive to the right. So it's important that you get that right. You can kind of get your robot to drive, and then you go to pose estimation and path planner and stuff, and you'll be kind of chasing that all season. So it's important that you understand that. And then on the field, in a similar way, X is downfield from your alliance wall, and Y is to the left. Rotation is counterclockwise. So I created a new article on WPI Lab that just got published last week about the coordinate system. It talks a lot about what we just looked at, the robot, as well as the field, and then how that relates to joystick input, and the fact that the last 2 years, the field is mirrored, not like a rotated copy of it. So like if you're on the left on this blue alliance, your charge station is kind of to your left. But if you're on the red alliance, your charge station is to your right. They're mirrored. So you couldn't just run paths the same on both sides. You had to flip them. So it's going to be that way again this year. So I have a couple strategies on there how to deal with that. Some of the tools like Path Planner, they're saying just use this coordinate system all the time. The blue side is where 0, 0 is in the blue corner. And then X is downfield toward the red wall, and Y is to the left from behind the blue. So pose estimation strategies. You use tags to estimate your robot's pose on the field. That's really what our goal is with April tags. Could also look at a tag and kind of treat it like we used to with retro reflective tape, where you kind of try to get the tag in the center of your view and kind of just, based off where the tag is, try to do some work. But the more advanced thing to do is to use pose estimation. And if you've done odometry before for like path planner or trajectories, you're already halfway there. It's a really easy thing to plug in on top of odometry. We configure the pose of the tag on the field, and that's built into Photon Vision. I think for Limelight, you have to go to Chief Delphi and find it right now. I'm expecting he's probably going to release some software that has it built in for this year, but where all the tags are on the field. And then you have to configure where your robot or where your camera is on your robot, because you're going to get an estimate of where your camera is, but you probably care about where the center of your robot is, especially if you have multiple cameras. So we would see a tag, we're looking downfield here. We see a tag up here. Here's our robot. This is our camera on the robot on the front. We can see the tag. And then we'll get a transformation from our camera to the robot. We have to configure that. So, on this one, maybe it's back 0.25 meters and it's right in the center, so it doesn't move. And then photon vision or limelight knows where the tag is relative to the camera. So we can flip that around and say we want to find a target to camera transform, and then transform that to where our robot is. Limelight and Photon Estimator do that for you. So when I gave this presentation last year before the season started, I went a lot more in depth on how to do that with the geometry classes, but now they just do it for you. If you get that stuff configured in your Limelight and your Photon Pose Estimator, you just start asking it where your robot is on the field and it just tells you. So the WPI Lab pose estimators are what I was talking about, where we feed that data in. You give it your wheel encoder values and your reading from your gyroscope, which odometry. That's the same thing that you do if you're using odometry now to get your pose on the field. But then there's a different class that you replace it with, and it has a method on it that says add vision measurement. And you just feed in those measurements that Limelight or Photon Vision give you and say, here's where a vision target said I was, and here's the time that it said it. And it does the math and calculates where you are on the field by fusing the odometry and the vision. And then you can configure it to trust one of those measurements more than the other. So you probably want to trust your gyroscope more than you trust the angle from an April tag. But over time, especially your odometry is going to drift because your wheels are going to spin, or somebody hits you and you rotate, or you come flying off the charge station like Emperors last year and you lose track of where your wheels are. So you can configure it how much you want to trust it. It does have a very sensible default, so you don't really have to worry about that unless for some reason you're seeing something that you want to tweak a little bit. And then they have different variations of that pose estimator depending on what kind of drivetrain you have. If you have a differential like a tank or West Coast drive, Mecanum drive, or Swerve, there's just a different version of that class because odometry is different. As far as the vision tags, it's exactly the same. So if you're using Photon Vision, your code would look something like this. You have to configure a robot to camera transform. So it has a translation component, which is to get from the center of the robot to your camera in X, Y, and Z. So in this example, the center of my robot is forward 0.06 from the center of my robot, and it's to the right 0.2 meters and up 0.2127 meters. And then you do your rotation. And the first one is your angle side to side, your yaw. The next one is your pitch. And then the last one is the last angle. What do you call it? You can look it up. So we have the three things to say exactly how to get from your robot to your camera. And then we create a photon pose estimator. You tell it what field you're going to use. WPI Lab has the fields built in. This is using 2024 or 2023. Now you can put 2024 in there and it'll automatically load it. And then you say, in this example, I'm going to use the multi-tag PNP that we talked about running on the coprocessor. So you just pick that. New photon camera, and you give it the name of your camera. You configure the name in the UI in Photon Vision. So it can be whatever you want it to be, but it has to match. And then you give it that robot to camera transformation that we created right here. And then in your periodic method, usually people put this in their drivetrain because that's where you have access to all the odometry stuff, you probably already have odometry there, and you're just replacing your pose estimator. So then you call that photon pose estimator.update, and that will check the network tables, find out if it saw a tag, what your latest pose estimate is. If it doesn't see a tag, it returns an empty optional. If it does, then it returns an estimated robot pose. So this little if present is a way to deal with if there's no tag, then it just skips. Otherwise, it'll go in here, give you the estimated robot pose, and then you call that pose estimator that you use to replace your odometry with the vision measurement. And that estimated pose that it gives you has both an estimated pose as a pose 3D, which you only need a pose 2D because we don't care about the height of the robot off the ground. And it also tells you the timestamp that it captured the image. So the timestamp there is actually when it captured the image, not right now, because it probably took a few milliseconds to process the image, and then it took a few milliseconds to get over the network, and then probably it was a few more milliseconds before your robot got around to checking. So this will actually tell you the time, a very good estimate at least, of when it captured the picture. For Limelight, this is how you have to do it if you use their Limelight library. I sent them a pull request, and I've got a link down at the bottom to my repo to have it calculate the timestamp for you. So if you use that, or maybe if he accepts it, I sent him an email. He said it looks good, and then he hasn't merged it yet. But you can say you want to get the bot pose estimate, and you say which coordinate system you're using. So I think this year my recommendation would be to say it's always blue. So always do WPI Lab blue. Last year maybe you would do it based on which alliance you're on, but I would say do blue, and then it'll give you an estimate of where you are with blue as your origin, and then you just pass that into that pose estimator. So you can get the estimated pose and then that timestamp of the estimate. That's about all I've got. A couple links where you can get some help. Photon vision documentation, they've got some pretty good stuff out there. Definitely look at that if you're getting started, because there's some links to how to set it up on different coprocessors. Like on the Limelight, if you're, or I mean on the on the Raspberry Pi, if you're using that global shutter camera that I mentioned, there's an extra step that you have to go into the config and uncomment a line. So make sure you go check that out. Chief Delphi, of course, great resource all the time. I asked for some help on there today, and within a half an hour, I got an answer that I needed. There's a Discord server for Photon Vision if you can handle Discord. And then there's a Limelight documentation. It looks like that's all revamped this year, so it's got some good layout and a lot of good information there, as well as the WPI Lab documentation. So that's what I had for like the boring presentation part. I was kind of hoping we'd have some roundtable part now with some good questions.
Andy, can you tell us a little bit more about so you talked about the timestamp of when the thing was captured. Does that mean that there's some built-in time synchronization code between the coprocessor and the RoboRio so that somehow it initializes and sets the seconds and start? Or I mean, it doesn't know what the actual time is, so it must be doing something like milliseconds and start, and it somehow synchronizes that with the coprocessor?
Yeah. Last year, Network Tables 4, NT4 came out within WPI Lab. Both of the coprocessors use that, and it has built-in time synchronization. So it's built into WPI Lab. It handles that for you.
Okay. Yeah, because it's been a while since I've dug into this, but I know years ago I was frustrated that there wasn't a way to kind of figure out when this thing was captured. So that's good to know they've added that.
Yeah, and that's how it calculates it. Actually, it kind of says when was the data put on the network table entry, and then the coprocessor keeps track of like how many milliseconds it took from the time it captured it to when it put it on the network table, and then you just calculate based on that. So yeah, it's helpful for sure to have that synchronization. Without it, you're just making a guess.
That relieves a lot of my anxiety with trying to get position while driving. With your testing that your team has done, do you feel like capturing a position while driving at quarter speed is even full speed possible? I mean, what's your thoughts on a speed that's okay to be able to continually recapture your position when you're just kind of flying past an April tag?
We had it on the whole time during teleop last year, and it worked really well. We did use a global shutter camera. I think that makes a difference to have that, because you can capture really well. But like, I don't have any recordings or anything from when we were at the events, but when we were in the shop, like, he would spin around at full speed and it would capture some images as it passed by. So it was working at full speed, and we used it last year to so the driver would drive into the community and then push a button to drive in front of the scoring location that they wanted to score to, and then it would use the retroreflective tape to align, but it would drive over to the right grid, and he said he used that very consistently. It worked really well. So right along there were all those tags that it could see right in front of the robot.
That's great.
Yep, I see we had a question from Walter. Raise your hand.
Sorry, my mute didn't go off.
Sure.
So would you recommend photon vision over just straight limelight? Our programmer tried to flash the photon image onto our limelight, and I wasn't there, and she couldn't do it. So we kind of moved forward with limelight, and right now everything's working. We just need to figure out the camera to robot transform stuff.
Mm-hmm.
And so, but it seems like photon vision it gives you a lot more just right out of the box.
Yeah, limelight is a good solution for sure. Like I said, the real disadvantage to it is that it doesn't have a global shutter camera. Otherwise, I know it's viable. A lot of people used them last year. It does work really well. It's easy to plug in and get working, and it has a pretty cool visualization that you can see where your robot is in the UI and help tune if it's working right or not. But yeah, like I said, photon vision has that ability to use a global shutter camera, but there is more tinkering. You have to go through that step to do calibration, and sometimes it's a little tricky to get it to do that if the lighting is bad or something. So it kind of depends how much you want to tinker with it. I think you can get a better result with photon vision in the end, but it's a lot easier to get going with limelight.
Right, thank you.
Sure. Yeah, Nate, you have a question?
Yeah, with photon vision, do you have a recommended frames per second and latency that you want to feel like you need to be above to be able to get, grab enough information to, if you're driving, to, figure out where you are in the field? Or is there, what's the threshold on average? I know that's resolution based as well, but.
Yeah, I don't necessarily have a number there, but it matters less than it did like with retroreflective tape, right? Because there, between images, you had no other information. Where here you're fusing it together with your odometry. So even if you're only updating once a second, you're still going to get some reasonable data, right? But we were able to get like 20 frames per second with one camera pretty consistently on a Raspberry Pi. I've been messing around with the Orange Pi, and I put 2 cameras on it, and it was getting pretty close to 50 frames per second with both cameras. So, I mean, I think that's pretty good. I don't know how much it'll matter to do more than that, because like I said, it's time stamped. So it does, kind of unroll back in time and then apply your odometry between images, as well as filling in the gap.
And with the Orange Pi, are you using a USB, or is it a different
Yep.
type of connection? Those.
Yeah, they're USB. Yeah.
Andy, do you have any recommendations for how you organize your code? I'm guessing that you would create some type of a vision subsystem and hand that to your drivetrain, or do you just put all of the vision code right in your drivetrain and you maybe just bubble up your pose so that your shooter can determine what your pose is or something?
Yeah, I would say probably just put it in your drivetrain subsystem. If you're using all cross-the-road electronics devices on a swerve drive, you have all CAN coders, all Falcon or Kraken motors, and a Pigeon 2. I would recommend using the TunerX generator to generate your initial project, and it does all of the best features of swerve drive, and it has this vision already exposed. So it'll generate a project where you just plug in your Limelight or Photon Vision code, and it's seriously like 4 lines of code, and it's working already. If you're doing it yourself, I think probably the drivetrain is the right place to do it, especially if you already have odometer in there. Last year, I did put it in a separate subsystem, and the big reason was because that multi-pose PNP was running on the Robo Rio, and sometimes it would take an extra few milliseconds, and we were getting loop overruns. This year, having that on the coprocessor, I'm expecting that's not going to be a problem. But I guess if it is, then maybe you want to move that into a separate thread. But I don't think it's going to be a problem because it's really just picking that data off at the network table now. It doesn't have to do that calculation on the Robo Rio.
And then from your drivetrain subsystem, you would just expose the 2D pose objects so that you would know what you'd have to elevate your shooter to or something like that.
Right. Yeah. The same way you would do with odometry to work with like Path Planner. You just have a method that would, get estimated pose, and it would give you back a pose 2D. Yeah.
Got it.
Yeah, Owen.
So, I am current. You mentioned like 50 frames per second on an Orange Pi.
Mhm.
I'm not currently there yet. I calibrated and I'm currently going around the resolution that Photon Vision recommends in the docs. Is there any other? Because right now it's operating around 15 or so, I say, on the single camera. Should I just bump up the thing in the Photon clients, or try some what other Photon client stuff should I try to bump up the frame rate, I guess? And I
The
have another one
biggest
after
is
this.
biggest is the resolution. The lower the resolution, the faster it's going to go. But there's a trade-off there, so you'll have to kind of make that decision.
Yeah.
It does
Yeah.
make a difference, that exposure, both because it can capture the picture faster, but if it's lower exposure, there's less detail that it has to go through. So it'll depend what your background is too. But if you can darken some of the stuff that doesn't matter,
Yeah.
and it just can see the tag, it'll process faster. There's also I believe it's called Decimate in Photon Vision that you can turn on, and that'll downscale the image before it processes it, which kind of gives you the same result of just reducing the resolution in the camera, but it's something you can mess with and see if that helps too.
I definitely need to play with that more. And also I had another one about the the color object detection at all. Do you think that's worth going into at all?
I haven't tried that in a while. I tried it a couple of years ago, and it was really slow. It didn't work very well. Yeah.
So I talked to someone else about it, and and they were kind of iffy about that too. I just want to get your opinion on it. Thanks.
Yeah. Yeah, Scott, go for it.
Can you go back to the slide that you had up with the field, and you were talking about always working from the Blue Alliance side?
Yeah.
So can you expand a little bit more on that? Is that what's the reason for that? Because I assume what you mean by that is keep your X and Y always in this corner of the field here, rather
Yep.
than switching it to the other corner when you're on the red alliance.
hmm
Is that so? What's the philosophy behind doing that? So always keeping it based on the same corner of the field every time.
It's a little bit simpler that way when you start working with April tags. So last year we did still flip when we were on the red side, that we moved the coordinates to the other side. So then when you load that field, you have to tell it that your origin is red, which is built into WPI Live, so it'll know where the tags are in relation to that. But if you want to say put your pose on shuffleboard, in shuffleboard you can't change the field image, so it's always blue is in the bottom corner. So up until last year, like, that was fine. When I'm on the red alliance and I'm driving around on the blue alliance, I'm still driving around the same field elements. But last year, that's different now because it's mirrored. So if I'm driving around up here, I'm actually driving on the charge station. So that was one reason. And then if you saw a tag, this was the thing that like was kind of tricky to deal with, was say you put your robot on the field and it sees a tag. Before it connects to the FMS, which coordinate system should you use? And then how do you deal with that? So if I'm on the blue alliance and I put my robot down and it sees that blue tag and then it connects to the FMS and it says I'm on blue, I'm fine. I estimated the right place. But if I was actually on the red alliance and I saw that red tag, the coordinate of that tag on the field is different if my coordinates are on the red side. So then we had to say like, oh, did we see a tag yet? If we did, now you have to flip so that you're actually on the other side dealing with those other coordinates. So you don't have to do that if you keep it the same all the time.
That makes sense. And then, so when you're talking about did I see a tag, that's basically the robot's figuring out where am I sitting on the field right now while I'm waiting for autonomous to start.
Yeah, right.
Okay.
Or just really before you connect to the FMS. So like a lot of people turn their robot on in queue so that it's fully booted up, and then they carry it out on the field. While you're carrying it out on the field, you're not connected to the FMS probably yet.
Okay.
And so it doesn't know which alliance you're on. And so you'd have to deal with when you do connect and you find out what alliance you're on, dealing with where you are on the field.
I see.
You could
so
either
that takes away
you could flip it, or you could say don't look at the tags until I'm connected to the FMS or something. There's strategies that you could do, but it's one of the tricks you have to deal with.
I admit I'm much farther out of the loop than I'd prefer to be in a typical year. I'm spending a lot of my time with our CAD students this year and less time with our programmers. So I only speak to our lead programmer, our student who's doing all this April tag stuff. And I think I've heard him say that he's not using the official Photon Vision, or he's using a port, or he's using a different thing that does the same stuff, but it's not. Are you aware of these other systems that students are trying out or teams are trying out and know anything about them?
No, I don't. I know there's some stuff built into WPI Live. And if you were to do that, you could plug a camera into your Robo Rio and do the processing. You'd be lucky probably to get 4 frames per second if you do that. But as far as other coprocessors,
I know that he's running on he's running on a coprocessor, and he was saying that he was getting faster times than using Photon Vision, and we're not using a Limelight. So I admit ignorance because I don't know what he's been testing, what he's been playing around with. I know that he's trying both. He was running Photon Vision on Saturday because I could see it running on the laptop, but I was just curious if you had any thoughts or feedback on these other April tag vision systems that teams are trying, because I don't know enough about it, not as much as I wish I knew.
Yeah, no, I haven't really looked at others. Yeah, I'm sure anything that you could do to process and then put it on the network tables you could deal with. Yeah.
Just to cut in, I think, Scott, it was WPI lib pi.
one final thing on that coordinate system, tool like Path Planner are going to use this coordinate system this year. Last year they did not. So it's always going to be blue this year. So if you're doing something different, you'll have to also deal with the fact that Path Planner, if you're using Path Planner, doesn't expect it to be that way. So something to think about. Yeah. So Walter, I think you had your hand up.
Yes. Has anybody played around with the Coral? We bought one, and I was, if we have time, I want to get the students just playing around with it. Being able to identify a note. I think it'd be actually pretty easy to identify a robot. So, like if you were going out in your auto and trying to get some of those notes in the middle, you could identify whether there was a note there or not. So you're not going to a spot where somebody's already taken a note. Or if you're just driving headlong into a note and there's another robot coming, you could make a decision whether you want to keep going or not.
Yeah, last year we did use a Limelight with a Coral, and Limelight just provided a pre-trained model that could detect cones and cubes. And so we used it for our intake. They would push a button and it would identify a cone or cube and then chase after it and pick it up. This year, I don't know if Limelight is going to provide a pre-trained model, but you can train your own. And I've seen on Chief Delphi that some people are working on collecting data and training some models. You certainly could do that. Yeah, we had success with it last year.
It doesn't seem hard with the note this year. It pretty much has one orientation.
Yep. Yeah, we messed around with it. Well, not with a Coral, but with object detection in 2022 with NVIDIA Jetson. And then it turned out our driver could just do it way better with a nice wide intake. So we didn't end up using it on the final robot, but we collected some data. Like we went at the week 0, recorded video with our camera on board, and then brought that back and captured frames and trained the model. And it seemed to work pretty well. Owen, did you have another question, or were you just mentioning?
Yeah.
Okay, go for it.
So we have an idea of using 2 coprocessors on a robot. Could you one, would you consider that a good idea potentially? And 2, what can you go into detail on implementing that into code? Is it another photon pose estimator, or even with 2 cameras even?
Yep. Yeah, you could definitely do that. Yeah, we're talking about that. Maybe up to 4 cameras, because if with a swerve drive you could be facing any direction, and so if you want to shoot or if you want to make your way around the field, you may not be able to see a tag. So if we're talking about multiple, which maybe means multiple coprocessors. From the robot side, it doesn't necessarily care how many coprocessors you have. It cares about how many cameras you have. So you would, create separate. Where did I have that code here? Separate robot to camera, because your cameras would be in a different position, and then a separate photon pose estimator because your camera name would be different, and then your that robot to camera. And so you would just use this same thing in a just make a copy of it and use the other pose estimator, but plug all of those values into add vision measurement.
Yeah, that's about what I thought. Yeah, thank you.
Yep. Yeah, and same with Limelight. There's an optional parameter that says what is the Limelight name. In this example, I put Limelight in it. If you put an empty string, it's Limelight. So you just have to go name your Limelights unique, and then you can grab them. Yeah, what else? Other topics. How about powering your coprocessor? What if if you use something other than a Limelight, any successes or failures with powering your coprocessors?
I actually we bought I forget the actual name of it, which is really bad now, but we bought like a thing off Amazon where you can plug it into like, I'm not a wiring person, so you just plug it into the voltage, I forget, and then it just gives you a USB port, and I can plug in. I plugged in to that. Yeah, sorry,
Yeah.
I can't remember exactly right now.
Yeah, last year we bought a little same thing, like a little converter that you'd put in your car that it's about this big and it takes 12 volts and then outputs a USB-C, and we plugged that in. We put it into the power distribution hub at first, and then found that sometimes the power was too dirty and the Raspberry Pi would freeze up. And so we bought a little universal power supply that had a little battery on it, and then found out that was illegal. So we weren't able to use that, but we plugged our power supply into the voltage regulator instead, which was probably what we should have done to begin with. And that seemed to take care of our problem. But last year, you weren't allowed to use a USB like phone charger large enough to power a Raspberry Pi. This year you can. So that's my current plan, is to use like a phone USB battery pack on there. You got to make sure that it meets the rules. There are specific requirements about how much power it can output and how much, how large the capacity of the battery can be. It has to be an off-the-shelf product with no like an integrated battery. So you can't have anything like a universal power supply that you buy on Amazon, but something to think about. Try to get your power as clean as you can. I guess the other advantage to having that battery is that it doesn't shut off. There was a problem last year in Photon Vision. Once in a while, when it would shut off, it would lose the configuration settings. They made some pretty significant architecture changes in how the settings are saved over the summer, so that should be taken care of. But if you could keep it on with a battery like that, all day, or just shut it down at lunch and charge it, you might be happier to not shut it down dirty. Yeah, what's the question?
I'm just wondering, will we be able to have access to the presentation with all of your links and documentation?
Yeah, I can share that.
Thank you.
It's on our website too, but I'll drop the link in here. What other thoughts? What else are people doing for vision this year?
One other vision thing that KnightKrawler has done in the past, and we did it last year, is we use a Pixie Cam. So Pixie Cam's been around for a while, and it has a I2C or an SPI serial interface. It also has basic analog, but it uses color detection. And so if you can train the camera to look for, in this year's case, different shades of orange, then you could potentially use that. And I don't know if it's going to be a simpler interface than using photon vision, but that's something that we've used in the past. We used it last year, and we trained it to look for different shades of purple and different shades of yellow, and then we could drive to the cone that was the different pickup spots, those 4 spots out near the center line, and pick up another game element. And it's worked okay for us in the past. But depending on the lighting situations and how shiny the object is, like the cones turned out were pretty shiny. And so a lot of the cone actually looked white and not yellow. So it can be a little tricky, but that's something that we've used in the past, and they're very affordable cameras. I think they're like $60 on Amazon.
Yeah, we did that in 2020 too, actually. And then kind of found with that bright yellow ball that a limelight with a big light worked pretty well for that too. But it wouldn't have worked on a cone, like you said, with the bright light. It would have been too reflective. And probably this year, that color of the note isn't probably reflective enough that like a bright light on the limelight would work. So good idea. A little harder to interface with though, right? When you don't have network table, so you have to write a little bit of code, but it's not terrible.
Yeah, I think that our students found code, and we were talking to it on the SPI interface because, again, was it last year? Or was it 2 years ago that the Robo Rio had a I2C bug in it that would cause your Robo Rio
Yeah, it
to
still
crash?
does. Yeah. Mhm.
Oh, it still does. Okay, well that's good
Yep.
to know too. So I2C is a little bit dangerous to use, but you could use the SPI interface. You can get back an array of objects, and we found somebody who had written some code to basically deserialize that array that comes back and turns it into objects. So we've been relying on that for a while now, the last 2 years that we've used PixieCam. But it would be nice to be able to get something off of network tables instead.
Yep. Jeremiah, what's your question?
Hey, considering that we are not a very strong programming team, we don't have a programmer that's good about any of this stuff, and constantly calling on help from other teams. But we have a very expensive camera, the $400 Limelight. What's your advice? Just practice. Driving robot and doing that, or pursue any of this at all?
Well, the Limelight is pretty plug and play. I mean, I would say give it a try. It depends what kind of robot you're building too. Like how are you going to score? If you are going to drive right up under the speaker or drive right up to the amp, maybe you don't need it. But if you're going to have some kind of a shooting mechanism that you want to be able to shoot from a little bit of distance, I think it's going to be pretty tough to aim manually because you're not really going to be able to see that speaker when you're driving.
Yeah.
So then you might want to do something.
I mean, primarily with strategy, primarily amplifier. But what if you needed to shoot in the speaker because things change, the game changes up sometimes, and historically, in our regionals, we always, like I remember, our first year we had 2 rookie teams versus 1 veteran team, and so sometimes you have that, and so if you can step up, like we're working on this Caucus intake shooter mechanism, not so much that we want to shoot in the speaker, but if we needed to, then we can rise up to that. But it's not our primary game. But saying that, no one's gonna let you just come and park your robot and then release the nodes and then go back and do it as you wish. It's not like last season where you had the community where people can come and harass you in there. So that's kind of why I'm asking that.
Mm-hmm. Yeah, I would, say like I said, Limelight plugs in pretty easy. I think were you guys using Max Swerve, so you have kind of the base already with the odometry built into the sample code. I think So plugging in Limelight isn't too difficult to get it going, and then leverage those WPI live geometry classes. Tell your kids to take a little bit of time to understand those. You don't have to do math. You can basically say, where am I on the field? And I know the coordinates to the target, and you can just ask it, like, what is the distance between them? And it just does the math for you. So it's not as fun, as doing maybe some trig and figuring it out, but it's very accessible that way if you take advantage of those classes that are built in.
Thanks.
Yeah. Anybody have other things? Yeah, Isaac.
Hi. What are your thoughts on using separate pipelines to detect April tags as opposed to using like a mega tag setup where each pipeline for the individual tags would be separate, so you could clearly identify what you want to score or shoot for?
Well, the mega tag is just where it'll, identify multiple tags, and then because it knows where those are, it can give you a better estimate of where you are. If you're going to be able to process that and figure out where you are on the field, I would recommend just using that, right? You know where you are, you know where the scoring location is. Just do it based on that, and don't actually worry yourself about where the tags are. Let the camera take care of that. If you're not going to do the pose estimation where you figure out where you are on the field, then you would want to look at specific tags and figure out, like, I want to align to this tag to shoot into the speaker, or align to this tag to get over to the human player station, something like that.
Okay, so generally you wouldn't have different pipelines for separate April tags.
Right. No, yeah, I would use the multi-tag and let it tell me where I am on the field. Yep.
Okay, thank you.
Yep. What else? Anything else?
Yeah, I've got a question.
Yeah.
So with the pose estimation, I'm not super familiar with it, but there is WPILib has the ability to merge your vision estimation with your odometry from your gyroscope and your wheels and all that. Do you have any experience in that, or anyone on this call really? I know there's the ability to weight which one you consider more trustworthy or consistent, and has anyone have any experience with that? Throw out the odometry, during teleop, and basically thoughts.
Yeah, that's what we're talking about doing. Yeah, so you get to you use the pose estimator, you feed it your odometry, and then when you see a vision tag, you feed it information about where you are from the vision tag, and then it'll fuse the two. It does have very sensible defaults. We just ran the defaults last year, and it worked well enough for us. If there's some reason that you want to adjust that, you can change the standard deviations. You can go look at what the defaults are and copy that, and then adjust them is probably the easiest way to do that. It worked really well for us. Yeah, we ended up turning off April tags last year during autonomous, just because we had a lot of trouble getting our field set up exactly right. We would get it all set up, perfectly right on a Saturday and run for a few hours, but then we'd come in, on a Monday or a Tuesday after school, and we have to set it all up again. And we only have a couple hours, and if you take a half an hour to measure everything out, it was frustrating. So this year, I think we found a space that we'll be able to leave it set up, which will help a lot. But we did end up just having to turn them off during autonomous because we couldn't reproduce the field at home reliably enough.
Cool.
And then it's just how you used to run it, right? It's just odometry for autonomous. Yeah.
Cool. Oh, yeah. Thanks for sharing that. That makes a lot of sense. Did you have any? I saw some feedback on. So we kind of played with that last year, but didn't get super far with it or implement it in teleop. Did you see any issues when you get run into or bounce around or jar around, or did your vision kind of help your localization pretty well in those situations?
Yeah, the vision helps a lot with that. That's exactly what it helps with. Yeah. So the fact that last year they only had tags on the end made it harder. We did have a button for the driver to push that would drive him over in front of that single human player station, because he was having a little trouble with depth perception, right? Like, he could tell he was facing it, but he couldn't tell, was he far enough in each direction? So we had a button that he could push to do that. But when he was turned toward the human player station, we only had the one camera, and so he couldn't see a tag. But if he approached it, seeing a tag, and then turned, the odometry would work well enough. But otherwise, yeah, you're driving across the field, you don't see any tags. Other robots are bumping into you, and your wheels are spinning, or you're jumping off the ground a little bit, especially like over the cable last year. You could be jumping over that cable a little bit, and your odometry would get off. But then when you'd see tags, it would quickly snap back to where it actually was. So your frames per second is probably something that you'd want to take into account if you have really slow frames per second, but you think your measurements are really accurate. It might be worth turning up that standard deviation from the default. But if you're getting a lot of measurements and they're kind of noisy, then it's a pretty good setting by default.
Cool. That's just what I was looking for. Thanks.
Sure. Yep.
Andy, you had mentioned about how your measurements might be a little noisy. I assume it's less noisy if you're stopped, or maybe the measurements are kind of perfect when you're not moving.
Well, it depends, on the quality of the picture. But something that happens with April tags is if you look straight on, you can't tell what direction they're facing. So like if you're straight on with this, it's hard to tell in two-dimensional space, did I turn it a little bit to the left or a little bit to the right? So it's best to have your camera maybe low or high so you're not looking directly at the tag. Sometimes you'll see it straight on and it'll jump back and forth. It'll think it's slightly this way, then it'll think it's that way, this way, that way, this way, that way. And there is a value that it'll tell you how ambiguous is the pose. If you can see multiple tags, that completely goes away. So then that doesn't happen anymore. But if you're only seeing one tag, you can have that kind of ambiguity in the tag where it can't quite figure out where it thinks you are. And one of the things you can crank up in photon vision is like the number of iterations that it does. So if you turn that up, it'll give you a better estimate, but then it'll take longer to process. So, but I don't know. Anybody else have experiences to share? I'm not an expert. I just have experience from last year. But yeah, Isaac, what's up?
Hey, I just had another question about your pull request on the limelight pose estimation slide. So I don't know if it's just because we're not using a timed robot, but I don't ever recall using like time stamping all that often. Is there like a great advantage in using that with detecting April tags and your pose on your global pose on the field?
Yeah, to use that WPI live pose estimator, you have to give it a timestamp of when it saw the vision tag. So that's what it's doing. It's calculating back to when that picture was captured. Odometry, it doesn't. You just tell it like this is where it is now, and it assumes that's right. But because vision can be slow and it's coming over the network, you do have to give it a timestamp. Does that make sense, or did that not quite answer your question?
Yeah, that clears that up. Thank you.
Okay, sure. Did anyone use April tags last year? Did you guys have success with April tags? No? Nobody else was throwing cones, I guess. So like we used we used the April tags to get in front of the target, but then we did use the retroreflective tape to align to throw our cones. But for the cubes, that was completely with April tags. The driver would choose where they wanted to score, and it would slide over in front of the grid where it was going to score the cube, and then throw it up there.
I'm curious to know if anyone is thinking about using April tags for their end game. Does anyone have any thoughts on that?
To what end? How would you use that?
Well, one of the discussions that's happened with our group is that if we are going to try to trap, which we still haven't figured out how to do that yet, but if we're going to try to trap, we may have to, we have an arm that we have to raise up as high as we can possibly get it and then climb and then use some mechanism to score on the trap. And getting that arm up without snagging the chain or without hitting it on the stage could be kind of tricky. So if you could get your robot so that you could see an April tag, you could just basically hit a button and have everything be autonomous at that point to drive to the proper distance, raise the arm, drive and grab the chain, pull it up. Everybody kind of rolls their eyes and like, oh my gosh, that's super complicated. But then we point out that, well, it's probably less complicated than our multiple game scoring in autonomous last year. If you score 3 game pieces in auto last year with all the driving you had to do, it was probably more complicated than driving and raising and lowering an arm to make sure that you don't bang your arm underneath of the stage, and you can get it up between the stage and the chain. It's something that we've talked about. My programmers aren't super excited about it. And like I said, we still don't even know how we're going to score on the trap, if we can even do it. But it has been brought up.
Yeah, sounds great. I think, anything you can automate like that, it's going to be more accurate than having a human do it. We're highly flawed.
I'm very concerned about the number of steps it's going to take for the end game if you want to try to trap. If all you're doing is climbing on the chain, okay, there's not very many steps. But if you're trying to get a note up in the air and not to get tangled in the chain, and then every climbers grab the chain and then raise and then score, I feel like the fastest way to do that is exactly what you just said, Walter, is have it be all automated. And the April tag on that stage makes that potentially possible.
That April tag is the only one that's behind polycarbonate. Just something to think about. That, reflection wise, that one worries me a little bit. But you might be able to see the others too, and then depending where your camera or cameras are, that could work for you. You might care about your height then too, not just in 2D space, if you're going to try to figure out how high you are off the ground.
Well, I was thinking you'd have to turn off the camera as soon as you're ready to climb, because the camera angle would change because you'd be swinging on the chain and all of that stuff. So lots of things to figure out there. Any thoughts on whether that chain, if it's running through the vision of the tag, is going to invalidate the entire tag? Or do you think it's smart enough to kind of extrapolate, oh, this is still number 11, or this is still number 15. I can see enough that I can determine what it is.
I think it's probably going to mess with it. That'd be something to try. There's a dial there again that you can say, how reliable do I have to expect the tag to be before I throw it out? But the lower you dial it, then the crowd starts to look like April tags and stuff too. So yeah.
Yeah, it seems like if you can at least see it while you're driving up to it, your odometry isn't going to drift enough to matter, between the last time you saw it and when you hit that chain. I think you could rely on that.
Well, should we do a last call for questions? We're a little bit early, but we don't have to run right till 8:30. Anybody want to make a final call for questions? And then I suppose we could open the floor for 5 minutes if anyone wants to just ask general questions about the build season. Any final questions for Andy? All right. Hey, thank you so much, Andy. This has been eye-opening for me. I'm very much on the periphery of this year with vision, and this gives me a better sense of what our students can do, and now I feel like it could be more helpful on giving guidance or answering questions. So does anybody have any things they're struggling with, things they want to share in the last 5 or 10 minutes here with the build season? Anybody still waiting on parts that are keeping them from doing the things they need to do?
We got most of our Krakens, but we're still waiting on things to go on the Krakens.
We are supposed to get Krakens this week. We are still waiting for SDS parts that we ordered, I think, in the first week of January. We don't have an estimate of when they might come.
We ordered in November, and we're hoping they'll ship this week. Yeah.
What parts are those, Andy?
Well, we bought Kraken motors, and the spline on the Krakens is different. So anything that you want to put on the Kraken to run it, you need different parts. And those finally started getting released like last week. So we're still waiting. We like to use the Max Planetary or the Max Planetaries from Rev. They haven't finished that yet. That's hopefully coming out in the next couple of weeks. But the SDS splines, I think they were supposed to start shipping last week.
We
West Coast
received
has
our
been shipping some
splines.
stuff.
Yeah, we got
From-
our splines for the Krakens from SDS just last week.
Okay,
So hopefully
good,
yours are on the
good.
way.
Yeah, we got
Yep.
some from West Coast for our telescopes. We're still waiting on other telescope parts, but we did get our splines at least. Yeah.
So are the telescoping parts of those for your climber?
I don't think they're gonna be now because their last estimate was the end of February, and that puts us like a few days before we have to pack up for we're week 2 at GNR. So I don't think it will
Okay.
be. No. It was
Yeah,
supposed to
just
be
trying
when we
to-
ordered it in November, but then
Yeah.
it got held up by the Kraken parts, and then I think they sold the parts that they had. So now we're stuck.
Yeah, we're just trying to still finalize, think about climbing and, if you're trying to harmonize and how high do you need to extend and reach yet. If you're trying to do a trap, how far down you have to pull. And, I don't know if telescoping climbers are provide enough delta or not in that distance. And so just trying to still figure out our options to best meet our needs.
Right. Yeah, at first that trap, we were like, oh, that doesn't seem too hard. You have to lift yourself up and then you can reach. And then, you do the math with how far you're allowed to reach with your robot. And it pretty quickly becomes hard. You really have to pull that chain down far to be able to reach. It's a lot harder than it seems on the surface.
Yeah, and to go along with that is the idea. One of the things that we were discussing on our Saturday meeting was that if we build a climber to grab the chain around 28, 30 inches, which is kind of the low point, and we can pull all the way down to the frame, then that same mechanism also has to be able to reach up to 38 to 40 inches if you want to harmonize. And see the idea that you have to reach up that high and be able to pull that low all the way down the frame, it makes that climber really complicated.
Mm-hmm.
Anybody else have any aha moments in the last week or feel like they had a breakthrough with their robot and their design?
We've just been assembling our robot. We've been having a bunch of issues with just not having the parts we need. I think we're still waiting on a few parts to come in for our mount. I feel like this year, especially compared to last year, our team and from the other teams I've talked to, we all feel kind of like a bit behind schedule. That might be because last year there wasn't really an end game. We also had a much simpler robot.
Ian, do you have a local manufacturer that does you shoot the CAD over to them and they cut them for you, or is that
we only have one part this year that's being cut by one of our sponsors, SMC. That's our mount for our arm. That's going to come in hopefully by Wednesday. And then our goal is to get the robot done being built by Wednesday so we can hand it off to programming. I think that's a bit optimistic based on where we are right now. We finished our drive base and intake mounting, and the arm is kind of just waiting for the parts. And then our indexer shooter, we're doing an unqualified Quackos with a 95 intake. And the shooter is waiting to be put onto the arm, which is waiting to be put onto the robot. And then testing everything and watching as the handoff doesn't work will be a fun experience and headache.
One of the things that we're worried about with that handoff, because we have a separate intake from our shooter as well, is what happens when you pick up half a note. We're very worried about having a half a game piece stuck in a robot that we can't get out.
Yeah, what do the rules say about that? I know it says if you score, if it like generally still looks like a note, it counts. But what if you have half a note?
I'm less worried
I'd have
about
to go
scoring
check.
it than being able to get it out so that we
Yeah,
can
yeah.
keep
If it's
playing.
jamming up your mechanism, yeah.
Right.
But if it's stuck on your robot somewhere, was where I was thinking too, right? Like, oh, my mechanism still works. Half a note stuck somewhere. Now am I controlling more than one? But
yeah, exactly.
If you tear it in half, that's a tech foul. We learned that last year. We popped a couple balloons at Worlds, and yeah, people don't look highly on tech fouls.
I think the biggest challenge this year is going to be that somebody's going to damage a note pretty severely. We have found that if you get any kind of a nick in the outside part of the note, and then you push the two sides of the note together, it's almost always going to split on that note, on that crack, and it's gonna completely split in half. We've had that happen twice now, mostly because students were doing this and pushing the note completely together because they weren't thinking and they're just playing with it, and then the end pops open like that. So the idea that it looks like it's a full note because it's laying on the ground and the ends are close together, you run up to it, you grab one end of it, and it sucks it in like a snake. And whether it's a full note in a line or it's not, the idea that I got to be able to get this thing out of my robot is now a big concern.
Yeah, I don't think that. I think it's going to be more difficult for them to call a tech foul for a damaged note. Your robot pops a ball. It's pretty obvious you did that. But for a note, those things are going to get torn up, and they're and you tear up one that's 85% through. It's hard to say that you're the one that broke it.
Yeah, I agree. I think it's going to be difficult to figure out who is the person that broke the note. It might come out of your robot in two pieces, but that doesn't mean that it wasn't just hanging on by a thread when you picked it up because someone else put the big rip in it.
Yeah, and that was my question. Like, who did it pin that on?
Interestingly enough, Kettering had a kind of a robot in 3-day event. I think they had 8 or 9 robots there, and they actually were surprised that the notes didn't really sustain much damage or wear over the whole day of matches.
Well, let's hope that stays true for us.
Yeah, we all do.
All right. Any final comments before we wrap it up tonight? I see that Jesse posted a link in the chat here, a YouTube video of where his teams are at. Jesse, I always appreciate you guys sharing your weekly updates that way. That's awesome.
Thanks, Andy.
All right. Excellent. Once again, thank you so much, Andy. That was an excellent talk. I really appreciate all the insight and the information. If anyone is interested, Sam, I know that you and I had some exchanges about some possible talks. It'd be great if you want to put that on the schedule for sometime in the near term. Otherwise, we don't have anything on the schedule. It'd be great if I didn't have to, or one of the KnightKrawler students didn't have to scramble to figure that out, if someone's willing to sign up for a topic. Once again, it's team2052.com/roundtable. You can go there and sign up to host a topic, get the link on your calendar, sign up for the mailing list, all of that there. So if you're watching this on replay, team2052.com/roundtable to join the mailing list or sign up to host a topic.
All right. You have a list of topics that are hopeful topics or requested topics?
In the weekly email that goes out that reminds everybody about this, I list the topics, at least the last time I pulled them on the mailing list sign up form. There's a list of, hey, I'm interested in this kind of talk. So I pulled that list a while back, and let me pull up last email I sent out.
Yeah, I got it up there. Yep.
Oh, you want to just list them off, what they were?
Build season temperature, preparing to talk to judges, writing, which I assume for awards, running a respectful strategy meeting at competitions, intake designs, elevator designs, sensor and limit switch designs, pneumatic and programming, autonomous programming. So, okay. Yep.
Yeah, so those are great topics. If anyone feels like they have good questions around that, you don't have to be an expert. You can just say, "Hey, here's a list of questions I'd love to know," and get feedback from the students and the mentors who are on the call. Or if you have a presentation you want to share, all of that works. So please, if you're interested, please sign up. All right. Once again, thanks everyone. And once again, thank you to Andy. I hope to see everyone next week. And I hope you all have great success in your build meetings this week.
Thanks, Andy.
Bye, everyone.
Thanks. Bye.